All right, welcome to math class. Woohoo! So we're going to be going over systems more. I know we just recently covered it, but and so I will warn you, this is going to be a long video. So I suggest taking a break after every example, to be honest. This is going to go over a lot of word problems, but it's going to be good to go over one because it's probably going to give you a lot of answers to solve some of the word problems in your homework, but just kind of general, more strategies more than anything of how to proceed in tackling word problems. So let's start off easily. So how many place values in a period? Well, that's going to be three. Okay, so we're not starting off with a word problem, doing a little review. And so if we look at a period, and a period is kind of like the three places that we have in a number line. So as we go from ones to thousands to millions, so there's always three: one, tens, hundreds, thousands, 10,000s, 100,000s. So there's three periods, or there's three place values in a period. All right, let's jump into some of the harder stuff. So before we get into the word problems, let's there's some terminology to go over. And really what we're going to learn is kind of like the difference between dependent and independent systems. So we can go when we're solving our system. So the solution set is infinite. Like we're doing, we're drawing that line and we're saying, this is this is all the numbers. And let's get that visual up here. It's kind of so from forever to forever in both ways, those were all the numbers that fit our system. So if we're comparing two, so if we're comparing this 9x plus 12y equals 18 and 3x plus 4y equals 6, we consider those like two separate lines. If we were to graph them out and they lie perfectly over each other, it means they have all the same solutions for both of them. It means the system is dependent. So if the lines lie on each other, the systems are dependent. All right. So then we have some other ones where we start going through and figuring them out, and things just are not true when we're solving the system. Okay. And so we call that a false statement, so that the system is inconsistent. Like it just doesn't, we're the solutions for both lines. So look how they're apart. They have no points in common. So parallel lines running next to each other never have the same answers. Um, and so we call that inconsistent. Just a little definitions in there that comes up, especially decide to go on and further in math. It just comes up as like a test question. But good to know. But no one's gonna, no one's gonna. All right. So this is what we want to try to get through today. All right. We want to solve geometry problems using two variables. We want to solve money problems using two variables. We want to solve mixture problems using two variables, and then solve distance, rate, time problems using two variables, and solve problems with three variables using a system of three equations. That's everything we're going to try to get through, and it is a lot. Okay, so let's just start off with what are the steps for solving? Now, I love this, an applied problem. It's a word problem. Apparently, if we use the term applied problems, you're not supposed to get agitated. It's a word problem. So first, read the problem several times if you have to, until you understand what it's asking. All right, and then we're going to assign variables. We'll write the system an equation that relates to what we're trying to solve. Then we'll solve. Remember, hold off on trying to solve everything until you set up the problem. Then solve, state the answer. So does it seem reasonable? Like, so if you're adding 1 plus 1 and you come up with 3 million, does that seem right? Or is there something weird going on? And then throw your answer back in, replace the variables with your answers appropriately. because it should all work out. All right, deep breath. Let's jump in. So we're going to start off by trying to find the dimension of a parking lot. So the length of a rectangle, the length of a rectangular parking lot is 20 feet more than 3 times its width. The perimeter of the parking lot is 800 feet. What are the dimensions of the parking lot? So we read the problem. And we're just trying to find out what the dimensions of the parking lot are. We have the answer. The perimeter is 800 feet. We just need to know, like, and we know that the length is 20 feet more than 3 times the width. So we just have to figure out what goes where to get this 800 feet. So we assign the variables. We'll let L be length, W be width. All right. So we'll write a system of equation. Because the perimeter is 800 feet, we find one equation by using the perimeter formula. And the perimeter formula, if you don't remember, is on a rectangle is going to be 2 times L plus 2 times W, length times width. But because the length is 20 feet more than 3 times the width, we're actually solving for L, right? So the length equals 3 times the width plus 20. So we have this system because we have 2 equations. We have 2L plus 2W equals 800, and then L equals 3W plus 20. So we have everything set up. So now we solve. So we go through, we substitute 3W plus 20 for L in the equation and solve. And that's what we're doing here. So we have our 2L plus 2W. We're just going to throw that in to where L is. We're going to throw the entire equation because we have a L equals, and we can do that. We're just going to throw it all in, and we're going to have 2 times the quantity of 3W plus 20 plus 2W equals 800. All right. We use a little distributive property. 2 times 3W is 6W. 2 times 20 is 40. All right, well, we're just going to let that be for now because now we have everything going. So we can combine like terms, right? We have a 6W and a 2W. If I have 6 W's and you bring along 2 W's, now I have 8 W's. And we just leave the rest of it. We're not going to mess around with it until we have to. So now we have 8W plus 40 equals 800. All right, let's do our thing. Let's isolate that W. So let's get rid of that 40. If we subtract 40 from both sides, remember, if we do whatever we do to one side, we have to do to both. That negates the 40. We're just left with 8W. Well, 800 minus 40 is 760. 8W is 8 times W. So the opposite of multiplication is division. We're going to divide both sides by 8. It leaves us with W. And 760 divided by 8 is 95. Oh, but wait, we're not done yet. So we know the width is 95. Let's throw that in. We're going to double check to make sure this all works out. But we're going to go back and throw that 95 into the other equation just to make sure that everything's okay. So W equals 95. Throw it in there. 3 times 95 plus 20. We're going to throw that in a calculator, to be honest. L equals 305. So now we know what both variables are. So now we can, and they seem reasonable, right? So the length is 305 and the width is 95. We go back, we plug in those values, and we find out that the length of 305 is 20 feet more than 3 times the width. Since 3 times 95 plus 20 equals 305, the answer is correct. Boom, that's how we do it. Probably the hardest part in all of this is setting it up. Once we set it up, we're just mathing. And so it's usually the uncertainty of what we're trying to do at first. So let's look at this next example. The local restaurant, the price of 1 soft drink and 2 hamburgers is $12.15. And the price of 5 soft drinks and 4 hamburgers is $32.25. Find the price of a single hamburger and a soft drink. All right, so we're going to write a system of equations. Let's just double back a slide here. We're going to go ahead and set up Right after we're done reading, we're going to set up variables. So let S be the price of a soft drink and H represent the piece price of one hamburger. Cool. We can do that. Then we're going to fill in information we know so we can build a system of equations. So we're going to build one equation, and we're just going to say, because one soft drink and two hamburgers equals 12.15, we're going to do S plus 2 times H equals 12.15. Similarly, the second one, because 5 soft drinks and 4 hamburgers is 32.25, we're going to 5 times S plus 4 times H equals 32.25. And it gives us our system. We have 2 separate equations to try to piece together to solve the problem. All right. So now that we set it up, we can do the math. So we're going to start off with, in this case, we are going to multiply each side of equation 1 by -5. All right. So we're just going to do some math. And the reason of that is to go ahead and start eliminating items. We're going to, looks like the example here is using the elimination method. So -5s, because -5, and the reason is the bottom one has that 5 and we want to eliminate it. So this is, elimination method isn't exactly my favorite, but this is the example being given, and it's good to try it with different methods. So we're going to multiply this first one by -5, because then I know if I have -5, and since the second equation has a 5, that they'll negate. So let's just try that. So -5 times S is -5S. -5 times 2H is -10H. -5 times 12.15 is going to be -60.75. And yes, throw that into a calculator. All right, so elimination method. We're gonna go -5S plus 5S is going to be 0. -10H plus 4H is going to be -6S. H, excuse me. We're going to go ahead and combine those two by popping them in a calculator. And we're going to end up finally with -6H equals -28.50. So we need to isolate that H. Means since -6H is multiplication, the opposite is division, we're going to divide both sides by -6, which just gives us H on one side, and then gives us 4.75 on the other side. So a hamburger is 4.75. All right, so let's plug that into the other equation. So S plus 2H equals 12.15, which if we plug in the 4.75 turns into S plus 2 times 4.75 equals 12.15. We're going to distribute, which gives us that 9.50. So S plus 9.50 equals 12.15. Right, we're going to subtract that 9.50 so we can isolate the S, and that leaves us with S on one side. And 12.15 minus 9.50 gives us 2.65. So S equals 2.65. A soda is 2.65. Odd price, right? But okay, we're just trying to work through this, try and get some math done. So now we know how much a hamburger is, and we know how much a soda is. All right. So then we know the price of a single soda is 2.65 and the price of a hamburger is 4.75. So if we put those back into the equation, 5 sodas at 2.65 plus 2 hamburgers at 4.75, that'd be 4. That's equals 32.25, which is correct. So that's how we can find out of how much something costs and like different combos, how much something, that's how we'd go about that. So I'm not gonna lie, this is a little more complicated, but we can get through it. I think we're kind of flying back by a little quicker than I thought we would, so that's always awesome. So example 3, this is what we call a mixture problem. We're trying to combine 2 different things to get a type of solution in different proportions. So how many ounces each of 10% hydrochloric acid, 25% hydrochloric acid must be combined to get 40 ounces of solution that is 22% hydrochloric acid. Okay, let's read that again. So how many ounces each of 10% hydrochloric acid, that's this one, and 25% hydrochloric acid, that's this one, must be combined to give 40 ounces of a solution that is 22% hydrochloric acid. Okay, that makes sense. Cool. Let's start assigning some variables. So we'll let X be the number of ounces for the 10% solution and Y be the number of ounces in the 25% solution. Okay, so what we're going to do is we've assigned those solutions. Can't really do math with the percentages, so we'll combine them to decimals so that it's just easier to do the math ahead of time. And we're going to assign the variables. Remember, X is going to be for the 10%, Y is going to be for the 25%. And then we want 22% solution at 40. So now we have we have 3 pieces to work with here. So let's start setting that up. All right, and now we have a system because we said X plus Y equals 40, that the 10% and the 25% at some variables, X and Y, will equal 8.8. So we're going to multiply each side by -10 because we see that 10 there, and we can undo that. So that we're going to convert it, and since everything was pretty much at 1, -10 gives us -10x plus -10y. The 40 multiplied by -10, 10 times 40 is 400. The -10x and the 10x cancel out. -10y plus 25y leaves us with 15y. And -400 plus 880 gives us 480. We have that 15. Let's isolate the y. 15y is multiplication, so the opposite is division. We'll divide by 15, which gives us our y, and 480 divided by 15, put into a calculator, gives us 32. So y equals 32. Okay, so we know y, and we have a pretty simple version of x. So we can go ahead and say, since 32 is what we need of the 0.25, we're trying to get 40, that means the rest of it must be 8. So now we've actually solved what the components need to be. We can pop those back into the equation, and we get the answer. So we need 0.8 of pure acid. So don't forget to go back from decimal percent. If you don't know your percent decimal conversions, let me know. We'll go over that. I love going over that. And 8 ends up at 8. So we end up with 8.8 ounces of pure acid. Woo, flying through this stuff. All right, so now we're going to move on to a motion problem. So our formula for motion is D equals RT, and that stands for distance equals rate times time. That's how we solve motion. So that's just one of those formulas that's never going away. And the important thing to know too is with formulas, just like we can rearrange things and do whatever we want to one side of like numbers, we can do the same thing with formulas. It's just remember, whatever we do to one side, we have to do to both. And that'll come up in a little bit. So let's read this problem. A car travels at 310 miles in the same time that a bus travels 290 miles. If the speed of the car is 4 miles per hour faster than the speed of the bus, find the speed of both items, both vehicles. All right, so assign variables. We'll let X be the speed of the car and Y be the speed of the bus. So we know that the car is going 310, the bus is going 290. We have our variables, so we don't know how quickly they're moving. So that's our rate. Distance equals rate times time. And we don't know the time, just double checking. So we're going to do 310 over X and 290 over Y. And so take a look up here. And this is how we wanted to know time. That means we have to isolate T. So R times T, opposite of multiplication division, I can divide both sides by R, which cancels out on this side and actually just gives us D over R. So to figure out time, all we need to do is do distance divided by rate. So that's how we can move around in an equation, like or formula. We can rearrange formulas to suit our needs. Okay, let's take a look. So we're going to start setting up our equations. So x, and because it says the speed of the car is 4 miles per hour faster, one equation is x equals y plus 4. So another one is that since both vehicles travel for the same time, so from the table we have our 310x equals 290 over y. If we multiply both sides by xy, just to kind of clean things up, we end up with 310y equals 290x. So that gives us our equations to work with, our system. So let's start taking a look. We're going to solve the systems of equation using substitution, because we have what x is. X equals y plus 4. So wherever I see a y, I'm going to replace it with y plus 4 using the second equation. So 310y equals 290x. 310y equals 290 quantity y plus 4. Awesome. We're going to distribute so 290 times y is 290y. 290 times 4 is 1,160. I have 310y equals 290y plus 1160. Let's subtract 290y, get that over, get eliminated on this side, get it over the other side. Means I have to subtract 290y from both sides, which gets rid of it on the right side and gets us down to 20y equals 1,160. I want to isolate that y, so I'm going to divide both sides by 20, which just leaves me with y, and then 1,160 divided by 20, I throw that in a calculator, it gives me 58. Y equals 58. So now I know what x and y are. And y is awesome because it's a simple, like it's a number, but I can throw that y back in. So if I just throw that y back in, 58 plus 4, 62. So x equals 62, y equals 58. 62 is 4 more than 4, so it all makes sense. Just to make sure I can throw those values into the formula, and the times are equal for both of them. So like life is good. We have solved that. All right. So now we're going to do a problem involving prices. Oh my goodness, we're almost towards the end. Look, this one, it's so much quicker than I thought it was. A little flavored water there. Example 5, solving a problem involving prices. Okay. At a local bakery, a loaf of honey wheat bread costs $2.69. A loaf of sunflower bread costs $2.89. And a loaf of French bread costs $3.39. So we just upped the game. We have 3 different things we're trying to figure out now. So on a recent day, twice as many loaves of sunflower were sold as honey wheat. The number of loaves of French bread sold was 3 less than the number of loaves of sunflower. Total receipts for these breads were $95.58. How many loaves of each type of bread were sold? All right, we need 3 variables. No problem, we can do that. It's the exact same methodology. We're just adding another variable. So we read the problem. There are 3 unknowns. We're going to assign variables x, y, z. We're going to let x just be the number of loaves of honey wheat, y be the number of loaves of sunflower, and z be the number of loaves of French bread. Then we're going to go back into our problem and start writing the equation, because it says so many of these and more of these. We're just going to start figuring that out. Now we know that y equals 2x because we're reading through the problem. So twice as many loaves of sunflower. So keep your variables straight. Then honey wheat. Remember, honey wheat is x. So z, the number of French loaves, were 3 less than the number of loaves of sunflower. So we're going to have y minus 3. Then we're going to try to plug in, and then we're going to go in and plug in prices. So not only do we have those going on, we have 3 different equations. We do know that 269 is the price of x, 289 is the price of y, and 339 is the price of z. Remember which loaves go. We can't switch them up, which one we assign them. So maybe doing a little what we call a legend up there so we don't forget. These are definitely not do in your head problems. Okay. So now we've set up our system of equations. Now there's 3 portions of our systems. Not a problem. We can do that. But look, can one? We know what Z is. We know what Y is. So we can go in Y equals 2x. So that means we can plug in Y. We just, everywhere we see a Y, we're going to put in 2x. So that's a lot easier to deal with. All right, we're going to go through. So now that we've reduced things to 2 variables, we're just going to go through and solve. So we're going to plug in here. So we're going to multiply each side by 100. And it's going to make our numbers get much, much bigger. We're also going to be able to go through, because now we know what Y equals and we know what Z equals. We can just go ahead and put those in wherever we see them. So we have 269x. And now we're just, wherever we see a Y, we're going to put in the 2x. Everywhere we put a Z, we're going to put the 2x minus 3. And then we're going to distribute, which is going to get some bigger numbers. We'll go to the next one, but we can do that. We have a calculator. Look, we distributed. Now we have like terms. So we're going to combine our like terms. So now we have 1,525x minus 1,017 equals 9,658. Let's subtract, or actually add, because that's a negative, and the opposite of negative is positive. So we're going to add 1017 to both sides, which is going to give us 1,525x equals 10,675. No problem. Numbers getting big, but we still followed our rules of equations, so not an issue. We want to isolate that x, so we're going to divide by 1,525. We get x. We have 10,675. We're going to divide it by 1,525. Put that in a calculator. We get 7. X is 7. So now we know x, y, and z, but x is now like a simple, understandable number to go through. So now we can go through and replace x in these other two with 7. 2 times 7 is 14. We go to y, 7 minus 3, or y, because that's 14. Replace the y with the 14. 14 minus 3 is 11. Now we know how many loaves of each bread were sold. Like magic. And so now we have, and this is what we want to write in a solution set. But like we're rocked and rolled. We throw that back in. We could check all those prices towards the amount. That's what we do here. 269 times 7 plus 289 times 14, 339 times 11, and it all adds up to 9658. Boom, we're done. It was a lot more daunting than it seemed. And then when we just jumped in and did the work, it all worked out. We are awesome. We are amazing. We're doing word problems. We're doing application problems. We have loaves of bread. Life is good. I will see you next week.